this question here that says write down the modular and argument of the following complex numbers here. So now let me just try to explain something before we answer these questions here. So what we see here is a complex number that has been written in its polar form here. So basically here we have so a complex number that is written in polar form is like this here. So we have cos theta plus I sine theta like this here. So here R here is called the modulus of z here, which is simply given by x squared plus y squared like this here. Then the argument of z here is just the angle that you're given there. So in this case here we have theta. So if you're given a complex number that is in rectangular form there, then the argument can simply be found by the inverse of y over x like this here. Then the value of x is simply equal to r cos theta. The value of y is simply equal to r sine theta like this here. Okay, so now here this complex number that we have here can still be written in this form here, which is its polar form, where we say r here and we have our argument this side here. So let's compare it with the first question that we've been given now. So there we have z here being equal to 3 cos 2 alpha plus I sine 2 alpha like this here. So this here in polar form there, so it's simply equal to z here is equal to 3 and the angle that we have is 2 pi like this here. So now here we need to write the modular and the argument here. So basically for this one here, we need to say that if you compare it with the general form of a complex number that is in polar form, it's going to be like this here, where r here is the modular and theta here is the argument. So therefore when you look at this here, r here is simply equal to 3 and theta is equal to 2 pi there. So therefore the argument of z there, so the argument of z there is 2 pi or 2 alpha rather. Then the modular there is simply 3 like this here. So these are the solutions for A here. Now let's look at B. I'm just erase what we have here. Okay. So now B here we have cos 2 pi over 5 plus I sine 2 pi over 5 like this here. So now this here, if we were to write this in polar form, we simply have z here is equal to 1 and we have 2 pi over 5 like this here. So we compare it with the general form of a polar a complex number that's written in polar form. So you find that your modular in this case is 1. The argument theta here is simply equal to 2 pi over 5 like this here. Okay, let's look at C. I'm just erased what we have here. Okay, so for C there we have a complex number z a cos theta plus I sine theta like this here. Now this can still be written as A here and theta like this here. So then the general form of a complex number in polar form, so therefore the modular here is simply equal to A and the argument z there is simply equal to theta like this here. Okay, so there we have it. You just compare it with the polar form there, then you get your modulus there, and you also get the argument just like that.